Hello everyone, Professor Vaibhav Shah here. Hope you have gone through my previous lecture, Introduction for Engineering Curves. If not, then I insist you to go check that lecture first. It is covering all the basic concepts like what are engineering curves and its applications, understanding of conics with pictorial representation, classification of engineering curves, understanding of various engineering curves and its definitions, and nomenclatures that we will be using in our subsequent lectures. In today's lecture 2, we will be learning how to draw ellipse by concentric circle method. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. Let us begin. So now, we'll be understanding first step-by-step procedure to draw ellipse by concentric circle method. Before going ahead, let us understand what do you mean by concentric circle method. Concentric circles, that means two circles having the same coinciding center is known as concentric circles. So here we will be having two circles with the same coinciding center. That means we'll be having two circles with the same coinciding centers are known as concentric circle method. And in between these two circles, we'll be drawing our ellipse. That's why this method is known as concentric circle method to draw an ellipse. So let us start. It is a step-by-step procedure, but let us understand we need total 3 parameters to draw any ellipse. We need major axis of an ellipse, minor axis of an ellipse, and third, what we require is focal points of an ellipse. Focal point F1 and F2. So let us suppose in this example, we have given with two data, major axis and minor axis. So how to proceed? So step number 1, draw horizontal major axis length. After that, find out its midpoint and draw minor axis vertically. Now, name this major axis as V1 and V2. You can give any names, A, B, C, D, whatever you want. And we'll be giving name to this minor axis V3 and V4. Now let us understand step 2. Take half of the major axis. That means here we'll be taking V1 till this midpoint as a radius from any minor axis point, either from V3 or V4. We'll be cutting this major axis here to get this point F1 and here point F2. So once again, we'll be taking half of this major axis. Let us suppose we will be putting our rounder here. You have to put your rounder here at point number V3 and you have to cut this major axis somewhere here to get your focal point and major axis somewhere here to get your focal point. So what we have done is we have taken the half of your major axis on a rounder. We have put our rounder at V3 and we have cut this major axis at here. So we'll be having F1, and if we cut major axis on another side, we'll be having this point as F2. So these are nothing but your focal points F1 and F2. Now, next step, we'll be taking half the major axis as our radius and we'll be drawing one circle which will be known as your major circle or your larger circle. And after that, we'll be taking half of your minor axis and we'll be drawing another circle which is known as your smaller circle or your minor circle. So after that, we will be dividing both of the circles into either of 8 parts or 12 parts. You have to use your set square, 45 degree set square for 8 parts, and if you want to divide this circle into 12 parts, you will be using your 30 degree, 60 degree set square. Here we have used the 45 degree set square to divide both the circles into 8 number of equal parts. After that, we'll be giving numbering. You can either give numbering in clockwise pattern or you can also give numbering in anti-clockwise pattern. Now here we have given the numbering in clockwise pattern. So let us start numbering. So outer circle will be giving numbering with the dash notation and inner circle will be giving same number without dash. So now let us give numbering to outer circle first. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash. Similarly, we will be giving same numbers but without dash in inner circle 1, 2, 3, 4, 5, 6, 7 and 8. So now, after that, now step number 5. We'll be drawing vertical lines from each of the points of the outer circles. As you can see, each of the point of the outer circle will be drawing vertical line except the point 1, 5, 3, and 7. Why? Because this will define your point 1, V1 and V2 will be defining your major axis, and V3 and V4 will define your minor axis. So these are already our ellipse points. So we need not to draw any lines from these points because these are already our major axis and minor axis points. So now we'll be drawing vertical lines from each and every point of the outer circle or the major circle, and we'll be drawing from each and every point of your minor circle horizontal line, like you can see here, horizontal line from your minor circle. So remember that from your major circle we'll be drawing vertical line towards the inward direction of your circle, like this, for this point like this, for this point like this. So you have to draw vertical line towards your circle, and from your minor circle you will be drawing your horizontal line away from your center. So away from your center of the circle or away from the circle, that means in outward direction you will be drawing line in outward direction. So once again, from your outer circle you will be drawing line towards the inward direction of your circle, and from your inside or smaller circle you will be drawing line outward direction of your circle. So outward direction of your circle. So after joining this line, you will be having one intersection point and you will be having one triangle. So the triangle intersection points are nothing but your points of ellipse. So let us give numbering. So this point would be your major axis first point. This is your P1. So that means this will be your P2. This will be your minor axis point P3. This is P4. This will be your major axis point P5. This is intersection point P6. This is minor axis point once again P7. And this will be P8. After getting this point, you have to just join these points, intersection points, by a dark line, and you will be having one smooth curve generated at the end, which is known as ellipse. So once again, concentric circle method, that means we'll be having two circles with the same coinciding center. After that, we'll be dividing this circle into either 8 or 12 parts. After that, we'll be constructing vertical lines from your outer circle towards inside direction of your circle or inward direction. We will be drawing horizontal line from your smaller circle or your minor circle towards the outward direction of your circle. After that, we'll be getting intersection points, and after connecting this point, we'll be having the ellipse. So now let us understand it more clear by one of the examples. So draw ellipse by concentric circle method. Take major axis 100 mm and minor axis 70 mm long. So first of all, we'll be drawing one major axis horizontal line of 100 mm. So let us draw one horizontal line of 100 mm. After that, we'll be plotting major axis 70 mm long from the center point. So we have drawn the major axis. Note that this is half of your major axis. So if we are having half of your minor axis. So we have drawn this vertical line as your minor axis. It says that minor axis of 70 mm. That means from your center point, you will be drawing 35 mm above this line and 35 mm below this line. That's why your total length would be 70 mm. Now after that, let us give the naming. So you'll be giving AB for your major axis and CD for your minor axis. After that, you have to take center point till your B point radius, and you will draw one circle, and center till your half of your minor axis, and you will draw one another circle. So we'll be drawing two circles, one with your minor axis as a diameter and one with your major axis as a diameter. So these are nothing but your two concentric circles. After that, we'll be dividing this circle into 12 number of equal parts. So let us divide this circle into 12 number of equal parts. So note the procedure. We'll be dividing this circle into 12 number of equal parts. For that, we'll be using 30 degree, 60 degree set square, and you have to divide this circle into 12 number of equal parts. Now after that, we'll be giving numbering. So we'll be giving numbering starting from this point. So let us give numbering in clockwise pattern: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have not given numbering to A and B, so we'll be specifying this A and B point as intact because these are the points of major axis. So we have just given numbering except this point A and B. So that's why we are having this point as point number 10. So we'll be start numbering from this and we'll end somewhere here. So now these are your total 12 points, including your A and B. Now after that, we'll be giving same numbering pattern inside of this circle. So let us give numbering pattern in clockwise direction similarly: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here also we have not included A and B. That's why we are having 10 number here. Now after that, remember the procedure, we'll be drawing vertical lines from these outer circle points towards inward direction of your circle, and we'll be drawing horizontal line from your smaller circle or your minor circle towards the outward direction of this circle. So let us start the procedure. So we'll be drawing vertical lines from each and every point like this. Here vertical line towards the inside direction, inward direction of your circle. So these are your vertical line, inward direction of your circle. After that, we'll be drawing horizontal line towards outward direction of your circle like this. We have to draw horizontal line towards outward direction of the circle. After that, we will locate and indicate the points of intersection. So we'll start with the first point, then after second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, and 12. So 12th number point would be A and B. Obviously, we have not given the numbers to A and B because these are the major axis point. So these are our 12 points. After getting these points, dark point, you have to just connect these dark points by your pencil. You have to just join it by a smooth curve, by a free hand. So if you try to join this curve, you will be having this ellipse. So you have to make this ellipse darker. So in examination, I can just observe this ellipse, and this all of the other construction would be lighter, which will be your just a structural diagram behind your ellipse. So this is your method to draw concentric circle method to draw an ellipse. So let us see one more example. Construct an ellipse having major axis of 120 mm and distance between two foci f1 and f2 is 90 mm. By concentric circle method, draw the ellipse. So here the data is changed. So now major axis is V1, V2, which is 120 mm, and the distance between two foci are 90 mm. As we know, we need major axis and minor axis to draw an ellipse. So first of all, our task would be to find out its minor axis. So for that, let us start. So first of all, we have to draw one horizontal line of 120 mm, which is denoting its major axis, and let us give the name as V1 and V2. After that, the distance between focal length given, which is 90 mm. So we'll draw half of your focal length on the left hand side. 45 mm on the left hand side will be having this point f1, and 45 mm on the right hand side will be having focal point f2, and the complete distance would be obviously 90 mm between this f1 and f2. Now, as we know, your minor axis would be somewhere here on the vertical line, but the minor axis distance is not given. So our next task is to just draw one arbitrary vertical line on which we will try to find out or locate our minor axis points V3 and V4. So how to locate these minor axis points? So for that, we'll be taking the distance from V1 to O, which is half the major axis distance, and we'll be putting our rounder here on F1 point. And after that, you have to cut this vertical line somewhere here. You will be having this V3 point somewhere here, just above your major axis. You have to similarly cut this vertical line somewhere down here. You will be having this minor axis somewhere here. After getting this V4 and V3, you have to rub the additional portion of this vertical line. So now you are having this V3 and V4. So now you have to remember, for this procedure, you have to remember our previous equation. CF1 is equal to CF2 is equal to DF1 is equal to DF2, which is equal to 1 by 2 AB, or 1/2 major axis. Which means if we want to find, if we are having F1 and F2 and we want to find C, which is your third point, or which is your minor axis point C, or D, which is your minor axis points, you will be using this equation. So for this, the location of minor axis from your focal point F1 or location of your minor axis from your focal point F2, which will be exactly equal to half the major axis. So here we have taken the same procedure. So to locate this minor axis point V3 and V4, we have taken the half of your major axis. So total major axis is V1 to V2. So we have taken the half, that means V1 to O, and we have used this focal point F1 as a center, and we have cut this vertical line somewhere here to get V3, and we have cut this vertical line somewhere here to get V4. After getting V3 and V4, V1, V2, now we'll draw two circles, one with the center O till radius V2. We have drawn one major circle, and second circle would be from center O till V3, you have to draw one another circle. So one circle is your minor circle and this circle is your major circle. After that, we'll be dividing these both the circles into 8 number of parts, as you can see. So we have divided these both circles by 8 number of equal parts. After dividing these circles into 8 number of equal parts by 45 degrees set square, we'll be giving numbering. We'll be giving dash numbering on your outer circle in clockwise direction and without dash numbering for the inner circle in clockwise direction itself. So now let us give numbering on outer circle. So outer circle 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Similarly, we'll be giving numbering for inside circle without dash 1, 2, 3, 4, 5, 6 and 7. Next procedure is simple. We'll be drawing vertical lines from the outer circle points or major circle points. So you have to draw a vertical line towards inward direction of your circle. So we will draw a vertical line. Here we will draw a vertical line. Here we will draw a vertical line towards the inside or inward direction of your circle. We will draw a vertical line. We will not be drawing lines from your V1, V2 or V3, V4 because these are already our major axis points and these are already our minor axis points from which our ellipse would pass. We need not to draw any triangles there. Now after that we'll be drawing horizontal lines from each of the points of your inner circle or smaller circle. These horizontal lines would be in outward direction to the circle. So this will be a horizontal direction, horizontal line. This will be your horizontal line from your point, which is outward direction from the circle. This is the horizontal line, which is outward direction to the circle, and this is also horizontal line towards outward direction of the circle. After drawing this line, vertical and horizontal line, you will be having points of intersection here, 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 and here. So we will be finding out the point of intersection, and after that we'll be denoting it by numbers. Point number 1, P1, P2, P3, P4, P5, P6, P7 and P8. After getting all these points, you will be just joining these points P1, P2, P3, P4 until P8 by a smooth dark line. This will be your final ellipse with your major axis 120 mm and with your minor axis of suitable length. So here it is not said that find out the minor axis, but for our simplicity, we'll try to find out and measure this minor axis V3, V4 and we'll try to write down that minor axis of ellipse is so many mm. So now this was your example number 2. Now let us see one more example. A point is moving in a plane such that the sum of its distances from fixed points is always constant and is equal to 110 mm and focal length is 80 mm. Draw an ellipse by concentric circle method. So here the curve traced out by a point when it is moving in a plane and sum of its distances from two fixed points is constant in an ellipse. So which is, if we remember the definition of ellipse, it is from that statement. So here required parameters for concentric circle method are major axis and minor axis. So constant sum of the distances from two focal points are nothing but your major axis. So let us remember the definition. I have told you that time you have to remember this term, that P1 F1 plus P1 F2 is equal to P2 F1 plus P2 F2 is equal to major axis. So it was the term in which the summation of the distances of the fixed point from the fixed point is always constant and which is exactly equal to your major axis. That means this is the dimension of major axis is given and this is the focal length is given. So first of all, we will be drawing the major axis first as a horizontal line and we will define the points V1 and V2. This is the major axis of 110 mm. After that, identify the center point and try to locate your focal points 40 mm on the left hand side and 40 mm on the right hand side by F1 and F2. So total distance between these two focal points would be now 80 mm. In next step, we'll be taking the distance half of the major axis. So this is the total major axis V1 and V2. So we'll be taking the half of the major axis like OV1. We have to put our rounder at F1. Before that, we'll be drawing one vertical line from O, which is your random vertical line of any suitable length. And now we'll be putting our rounder at F1. Now we have taken the dimension of OV1. You have to put your rounder at F1 and try to cut this vertical line somewhere here to get your point M, which is a minor axis point. And similarly, you have to cut your rounder somewhere here. So you will be getting your minor axis another point, which is your point MN. So now this MN would specify you as a minor axis. So first what we have done is we have drawn one horizontal line V1, V2. After that, we have found out the center point as O. After that, we have to locate this F1 40 mm left on the left hand side of your major axis and 40 mm on the right hand side of your major axis. Why? Because the total distance between F1 and F2 is 80. So now after that, we'll be drawing one vertical line from this O on which there will be some point M and N. We don't know where it is situated. So now for that, we'll be taking half the major axis, which is OV1 on our rounder. We have to put our rounder at point F1, focal point F1. We'll try to cut this vertical line somewhere here to get this end point of your minor axis as M. And here, similarly, we'll try to cut this vertical line downward to get this point M. After that, we'll be dividing this circle into 12 number of equal parts by a 30 degree, 60 degree set square. And after that, we'll be giving numbering on the outer side of the circle by your dash points and inner side of your circle by without dash points. So here we are giving numbering in anti-clockwise pattern. So let us give numbering 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash, and back to 1 dash. Similarly, we will be giving numbering in inside circle but without dash 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. After that, we know the procedure. We'll be drawing vertical lines from your outside circle point or your major circle point or dash points, and these vertical lines would be towards your center or inside direction of your circle, and you will be drawing horizontal lines from each of the points of this smaller circle or your minor axis circle towards the outward direction of your circle. So let us draw vertical lines towards the inward direction of your circle from this dash point. So we have drawn vertical lines from each and every point towards the inward direction to the circle. And after that, we'll be drawing horizontal lines from each and every point towards outward direction of the circle. So we have drawn towards outward direction of the circle. Here also we have drawn outward direction of the circle, outward direction to the circle, outward direction of the circle. We have drawn the outward direction to the circle. Here also we have drawn the outward direction of the circle. After that, we'll be having the intersection point as your intersection point of your triangles. And after getting this point, you have to just simply connect these all the points to get your required ellipse. So here you have to remember to get your focal point or to get your minor axis point, you have to remember this equation. CF1 is equal to CF2 is equal to DF1 is equal to DF2 is equal to half the major axis AB or half major axis. It says that if you are having focal point F1 and F2, and if you want to find out C and D points of your minor axis, here in this case, our minor axis point would be M and N. So we can replace C by your M and D by your N. So we can have this M and N from this equation. So for that, we'll be taking half the major axis distance. We'll be using this F1 as a center. You have to just cut the vertical line here and upward direction and downward direction to get this M and N. Later on, you have to just simply follow the procedure. So now, this was all. Let us see one more example. Construct an ellipse by concentric circle method. The major and minor axes are 130 and 70 mm respectively. Also draw the tangent and normal to the ellipse at any suitable point. So we'll see the tangent normal in later lectures or later sections. We are just focusing on concentric circle method in this particular lecture. So first what we'll do is we'll first draw one horizontal line of 130 mm. After that, we'll be drawing one minor axis of 70 mm vertically. That means 35 mm up, 35 mm down. We'll be specifying these points as A, B, and these point as C and D. After that, we'll be dividing this circle into 12 number of equal parts by 30 degree, 60 degree set square. After that, we'll be numbering both the circles, outer circle first. So in anti-clockwise direction, let us start from the 0 .0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, we'll be giving numbering in inner side circle or smaller circle with the dash point 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and 12 dash. After that, we have to draw vertical lines towards the inward direction of your circle from your major circle points or your larger circle, and we'll be drawing horizontal line from your minor circle or smaller circle towards the outward direction of your circle. So let us draw vertical line from your major circle towards the inward direction of the circle. So we have drawn vertical line towards inward direction of the circle. We have drawn one vertical line towards the inward direction of the circle. We have drawn one vertical line towards the inward direction of the circle. From point 4, we have drawn one vertical line from inward direction of the circle. From 2, we have drawn one vertical line towards the inward direction of the circle. From 1, we have drawn a vertical line from inward direction of the circle. Likewise, you have to draw from each and every point. Now, you will be drawing from your inside circle or smaller diameter circle or your minor circle horizontal line towards the outward direction of your circle. So, we will be drawing horizontal line towards the outward direction of the circle. We will be drawing horizontal line towards the outward direction of the smaller circle. We will be drawing horizontal line towards the outward direction of this circle. We will be drawing horizontal line towards the outward direction of this circle. Similarly, we will be drawing horizontal line towards the outward direction of this circle. Similarly, we will be drawing outward direction of the circle. Similarly, for 11 point, we will be drawing line outward direction of the circle. We will be drawing outward direction of the circle. Now, we will be getting the intersection point at end point of your triangle. So after that, getting intersecting point, you have to just connect these points by a smooth curve. So we'll be connecting these points P1, P2, P3, P4, P5, P6, P7, P8 and P12. We'll be having this ellipse. And after getting this ellipse, your example is over. After that, you have to give dimensions, then what is your given axis, major axis, and what is your given minor axis. So now, this is all from my side. Do not forget to share with your friends and like and subscribe to show your love and support. Keep learning, stay connected, and if you have any doubts or queries, feel free to comment below. Bye-bye.